Hey guys, it's Gus from LeetCode Solutions, and this is going to be a channel where I'm going to be going through all of the available online interview questions from LeetCode. In particular, I think there are around 1,500 of them, and I will try to do as many as I possibly can. We'll see if time permits. I have a very busy schedule, like many of you do, I'm sure. Uh, but hopefully this will be informative for you guys and helpful for me in my coding practice. Another thing that's interesting about what I plan to do with this channel is that I'll be solving these questions in live time, which will hopefully provide you with an in-depth look as to how somebody thinks about a problem while they're actually solving it, rather than having seen the answer immediately beforehand and trying to retroactively explain how you should think about it, because that's helpful, but it's not helpful in the same ways that I think this will be. In particular, I hope that this could provide you with a framework to think about problems that are similar to the ones you see me solve on this channel. Now, with that in mind, I guess let's just jump right in. Let's check out the first one. Another thing to quickly mention before that, I guess, I have seen many of these problems beforehand. But I don't have the answers memorized or anything. In particular, this problem was probably one of the first ones I've ever done on LeetCode, so that was a while ago. Point being, it's effectively a clean slate for me, so you're going to be seeing the way that I think about a problem as I'm solving it. So let's jump right in. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. Okay. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so what's always helpful for me when I do these kinds of problems is looking through the examples, because they make what's explained up here more digestible. Let's check it out. So, given an array nums equal to 2, 7, 11, and 15, and our target 9, we want to find two values in this array that sum to 9. Obviously, 2 and 7 sum to 9, and they are in positions 0 and 1 in the array. Remember, array indexing in Python starts at 0, so we want to return those two indices, 0 and 1. And I believe the rest of the examples will follow pretty much that exact same format, which they do. We see 2 and 4 add to 6. They are in positions 1 and 2. 3 and 3 add to 6. They are in positions 0 and 1. Okay. A couple of things immediately jump to my mind when I see this problem. One, that we have exactly one solution in every array. Meaning that no other combination other than 2 and 7 will add to 9 in this array, and extend that to the general case, there will only be one combination of two values in nums that will add to the target value. And the other thing that jumps to mind is that we're not given a restraint on our time complexity here, meaning that it doesn't tell us to solve it in less than n squared time, or at, in particular at n, or at n log n, or whatever. Meaning that we are okay to write the naive solution. And that's, for me, the first thing that comes to mind would be iterating through the array and iterating through the array for each value. And what I mean by that is we are going to look through this array, starting with 2, and we are going to check every other value in this array, 2 with 7, 2 with 11, 2 with 15, and see which of them adds up to the target value of 9. And since 7 adds to that, we will simply return 0 and 1 before we even need to check the rest of the values in the array. And that's n squared because I think that's going to require a nested for loop. And what I mean by n squared, for those of you that are unfamiliar with that, basically the amount of time that it takes to run this particular program is proportional to the length of the input being nums squared. And that's because, again, we are going to check this array each value of this array against every other value in the array, and it'll be more clear as I'm coding. But let's jump right in. So the first thing I'm thinking, since we want to do a nested for loop, let's just create that nested for loop for I in range when nums blah blah blah. Let's do it again for j in range when nums. What we want to do is find the two values that add to target. So basically, if nums of I plus nums of j equal target, then we are going to want to return an array containing those indices. Just get a quick look at this. Okay, I realize I overlooked something slightly here. We don't want to iterate through the entire array twice because we don't want to use the exact same element twice. And what I recall from looking briefly at this example here is that 3 and 3, if this were the input array with our code right now, this would actually not give us the correct output. And that's because we would be checking first the 0th value in the array with the 0th value in the array, which is 3 and 3, and that adds up to 6, so we would be returning 0 and 0, but we don't want to return the same element twice. We want to return 3 and 3 over here, so the 0th and the first element. So with this in mind, we just need to edit the range that j is scanning through, and we need to make it greater than I at all times so that we're not checking the same one twice. And that should do it. Just making the range start at I plus 1 each time. And again, this is n squared time because we're checking the array against every value in the array. I in this range, j in this range. Let's run the code, see if it works for the current test case. It does. Rather than putting all these test cases in, I'm feeling pretty confident about this. I'll try and submit it, and if not, if it doesn't work, we'll try and see what we can do to fix it. It's taking a second to run because, again, the runtime is slow. And this is exemplified by the numbers we see here. We got a success, so that's good, but not a very impressive one. In particular, it's only faster than 17% of the submissions that have already been made for this problem, and uses about an average amount of memory. So again, this is okay if you're not worried about complexity, but if the input values were if let's say this was a very large array, we would want to find something much faster than n squared. In particular, we want to probably try and find a solution that has n time, and I believe that can be done in this problem, just glancing at it right now. And I think we can probably do it with a dictionary. So let's do that. Why not? Let's see if we can do it in n time. And for those of you who don't know why that would work, well, the way a dictionary works is that it has particular keys and values associated to those keys. Now, to find a particular value in a dictionary, you don't actually need to iterate through the entire dictionary like you would in a list to find a particular value. It has a direct reference to that key. So it takes constant time to find the value when you're checking if a dictionary contains a certain value. So we won't need to scan through the dictionary. We will only need to scan through the array, I hope. So let's get that started. First, since we probably want to try to do this with a dictionary, let's just create a dictionary. And if you guys are Java coders, this is similar to a hash set or a hash map, I believe, a dictionary. So let's continue. We have this dictionary. Let's initialize it with the values that are stored in nums. So and how do we want to construct this dictionary? We would probably want to be searching the dictionary to see if it contains one of the values in nums. And in order to do that, we need to make the actual keys the values in nums, and the associated values of those keys the index. So to do that, we will simply do this. We will do number dictionary of nums of I is equal to I. So to show you what I just did, let's just print this. Oh, not number dictionary. Hopefully this runs. All right. Of course it's wrong, we didn't return anything, but this is what we've created. So we've created a dictionary that contains the values in nums. We see 2, 7, 11, and 15. These are the keys, and the associated values with these keys are 0, 1, 2, and 3. And you can tell that these are the associated index in this nums array. We see 2 is at the 0th index, 7 is at the first index, 11 is at the second, 15 is at the third. And of course, it'll do this for any given input array. So what's nice about this is if I want to find a particular value in this dictionary, I could just do something like if 2 in number dictionary print true. I'm not going to do this, but basically it'll search it in constant time. It won't need to iterate through the entire dictionary because dictionaries are actually inherently unordered. It simply has a reference to those keys, so you can look at it without checking every other value. Anyway, let's get back to the code. I'll just leave that there for you guys. So what can we do with this dictionary? How can we use it to our advantage? Let's see. I imagine we are going to need to run through this array again. So let's get that going. And what can we do if we do that? Let's see. If we start with 2, then what are we looking to do? We are looking to find which other value gives us 9, and we are looking to see if that's in the dictionary. So I think I have a bit of an idea here. Let's create a parameter called temp, which is going to be an integer, which is going to be target minus nums of j. Let's do that. So for this example, if we're first looking at 2, target's 9. 9 minus 2 is 7, so temp's going to be 7. And what we want to do is we want to see if 7 is in this dictionary, and if so, what's its associated value to that key. Now we know by looking at this that that associated value is going to be 1. So the hope is that once we find it, we will simply return j, which is 0, and that associated key, which is 1, which is give us the expected answer. So in order to do that, we need a conditional statement. So if temp in number dictionary, and this is where I'm glad we made these the keys rather than the indexes, because we can just look up this number to see if it's in the dictionary. Then we will simply return this index, 0 in this case, and we will return the associated value here, so number dictionary of temp. Now let's see if this just works. Oh, and just in case it gives us a bad input, let's just return none. I think this should probably work. I hope. Maybe a little bit too much confidence. Okay, that looks good. Should I bother checking the other ones? Probably. Let's just see real quick. And this one was 6. Look at that. I'm glad we checked. What's wrong with it? Okay, so we're returning 0, 0, so I probably overlooked something again. Let's see. Okay, similar to what we did last time, I am looking at the same value twice. And how can we avoid that? How can we avoid checking 3 twice here? Because 3 plus 3 does equal 6, but we don't want to return 0, 0. So if temp in number dictionary, temp being target minus this, 6 minus 3 is 3. 3 is in this dictionary to the 0th position. And maybe we add something to this conditional statement to prevent that from happening. So and number dictionary of temp is not equal to j, because we don't want this particular value to be equal to this particular index. Now let's try and run it with this. Hopefully this should fix that issue. Perfect. Now let's try and put this one in, this test case with 6. Hopefully it'll be 0, 1, and then we'll try and submit it. All right, good. Okay, and last thing before I submit this, this should run in O of n time, meaning worst case scenario, it'll run in a time that's proportional to the length of the input array. Now, some of you who are a little observant will realize that we're actually scanning through the array twice, once to initialize the dictionary, and another time over here where we're actually checking to find the proper position values. But that doesn't end up mattering in the world of computer science. You're effectively saying it's O of 2n, but the constant coefficient doesn't matter. Again, complexity is based on what's proportional to the input size, so it's going to be O of n is the way we see it, which is going to be faster than O of n squared in the long run, given a huge sized input value. So let's submit this and hope for the best. Come on, come on. Get in. Cool. So look at this. Our new code here is 98%, is faster than 98.73% of all of the other submissions, and with that, we're also using a hell of a lot less memory, which is fantastic. So, yeah, I hope you guys found this video informative. I hope you enjoyed this content, and if you want to see more like this, please be sure to like and subscribe. It'll motivate me to make more of these types of videos, and it'll allow me to find significance in doing these. So thanks again, everyone, and have a good day.